All right, welcome to another video of Chem with Com. We're going to continue measurements, prefixes, and dimensional analysis. This is going to be the fourth video. This one we're going to cover still dimensional analysis, but now we're going to do something specific, and it's going from grams to moles to units to moles to grams, back and forth, and all sorts of stuff, right? The last video was kind of long. I wanted to keep everything in one spot. This one might be a little shorter, but not by much. This is really the what most chemistry students need to know before they leave, so we want to focus a lot of time on this. All right. So again, calculator, very important. Use those online calculators till you get yours. And remember, put brackets around all exponential notation numbers when using your calculator until you get better. And then you can start leaving them off when you know you can leave them off. But for now, keep them in. All right. So this is what we ended with. This is from the last lecture. This is just exact slide from last lecture. So we're converting something, in this case, Mexican pesos to US dollars. Find the conversion rate. It's a number unit equals sign number unit. Write it as two fractions. Forgot to do that here again. Mexican pesos. And then the third step is multiply the original value by the fraction. Use the fraction that has the same unit as the original value on the bottom. Since this is Mexican pesos here in the original value, we want to use the fraction with Mexican pesos on the bottom. What happens is the Mexican pesos cancels out and you get left over with your new unit, which in this case would be US dollars, right? For details, go back to the last lecture and that'll get you up to speed there. Highly recommend that one before this one. All right. Avogadro's number lets you convert from moles to units and from units to moles. Units in this class are going to be atoms, and just units just mean things, right? Atoms, but or molecules. I guess I wrote it on the bottom there. Right? So that's a conversion rate. 1 mole equals 10 to the 23rd things or units or atoms or molecules, right? It's just a number of things. If I said 1 dozen donuts, right? I could say a mole of donuts. I could say 1 dozen pieces of paper. I can say 1 mole of paper, right? And that number is 6.022 times 10 to the 23rd things, which is a huge, huge, huge number. All right. All right, grams per mole lets you convert from grams to moles and moles to grams. So if you get a question that says something like convert moles of boron to grams of boron, we know we're going from moles to grams. That means we have to find some sort of conversion that lets us do grams to moles and moles to grams, right? But it's the same exact steps. Find the conversion rate. This is 10.81 grams of boron equal 1 mole of boron. Write it as two fractions. In this one, I took the top part here. This one, I put it on the bottom. But you can see the other fraction just has them crisscrossed. But this is the important part. I mean, they're all important, right? But this is one that people get a little tripped up on. Multiply the original value, which is some sort of moles of boron. So we'll say question mark moles of boron. We don't know. We just made it up. Or let's just make up a number. Let's say 0.36 moles of boron. And we want to convert. Well, we have to use a fraction with moles of boron on the bottom. That's this one. 10.81 grams of boron to 1 mole of boron. We know the moles of boron cancel out, and our units are going to be grams of boron, right? So again, find the conversion rate. Write it as two fractions. Multiply the original value by the fraction. Use the fraction that has the same unit as the original value on the bottom. All right. But where do we do grams per mole? Well, grams per mole Remember, the units on the periodic table are in two different things, atomic mass units and grams per mole, or grams per mole, or grams per 1 mole, right? And these are those numbers. Hydrogen equals 1.008 grams of hydrogen per 1 mole of hydrogen. I can also write it as 1 mole of hydrogen, or 1 over 1.008 grams of hydrogen. This boron example, right? 10.81 grams of boron equal 1 mole boron. This is grams of boron per 1 mole of boron. We could crisscross these and make a different fraction. Let's just do one last one. Let's just look at cobalt, right? 58.93 grams of cobalt per 1 mole of cobalt. Or we could switch it, 1 mole of cobalt over 58.93 grams of cobalt, right? Any of those numbers, 50.94 grams of vanadium per 1 mole of vanadium. So these are built-in conversion rates. It lets us go from moles of something to grams of something, and then grams of something to moles of something. And we could do that with molecules, not just atoms, right? We could do molecules as well. If we wanted water, for instance, H2O, that's 2 hydrogen, 1 oxygen. So we look at the hydrogen. We have 2, hydrogen, we multiply it by 2, and each of those is 1.008 grams per mole. That's 2.016 grams per mole. Oxygen, there's 1 of them. Each one oxygen is going to be 16 grams per mole. So we add those up and we get 18.016 grams per mole. So 18.016 grams of water per 1 mole of water. And we just crisscross them. 1 mole of water over 18.016 grams of water, right? This is going to be our second fraction, right? First fraction's already there. Second fraction we create. All right. Let's go for it. So this is a little table that a lot of people use. Basically, this lets you figure out what to do. So if you're at grams, basically just like a little game board. If you're starting here at grams and you want to go to moles, you just have to cross number 1. So you're going to use the note for number 1. Use the grams per mole from the periodic table. For instance, water is 18.016 grams equals 1 mole, or 18.016 grams per mole, right? Or you can go back. You just do the same thing, but you just swap the fraction. Let's check this out. Grams of water, let's just say 1.5 grams of water. You would use a fraction that had grams of water on the bottom. 18.016 grams of water per 1 mole of water, right? Grams cancel out. You're left with moles of water. Let's say you had now moles. Let's say you want 0.01834 moles of water. Well, you would just use the reverse and put the moles on the bottom. Right? Because here, moles of water cancel out, and then your answer is left in grams per mole. Then, let's say you wanted to get more advanced, right? And you wanted to go from grams of something to, let's say, molecules of water. Say start, we're going to go grams of water to molecules of water. So then you would do what we just did here. But now to get to here, right, we have to use this conversion rate. And that is because we're going from moles of things to units of things, right? So we're going from, what's this case, we're starting at moles of water, grams of water. We're going to moles of water, and then we're going to molecules of water. Remember, H2O is a molecule, right? H is an atom. O is an atom. Right. So when we talk about these things, we have to classify things and we have to remember how to classify things. A single atom is an atom. When you start making when start things are bonding, they're molecules now. So you have to say the appropriate terms, atoms or molecules, right? And that'll keep you from getting tripped up. All right, let's keep rolling. Okay, let's just start doing stuff now. Okay, beryllium is a light metal used to fabricate transparent X-ray windows for medical imaging instruments. How many moles of beryllium are in a thin foil window weighing 3.24 grams? This is one of the harder things in chemistry, is you're taking these words and you're trying to figure out what to do with them, right? So I like doing whatever you're starting with, drawing an arrow and going to whatever you want to end with, right? And we want to start with moles of beryllium. And most of this, once you get better at this, you can pretty much figure out what to cut out. All that can be cut out. How many moles of beryllium are in 3.24 grams? Basically, that's what it is. So that's very, very little we actually needed. This is only the stuff we needed here. The rest is just stuff to put these in context, maybe to confuse you. I'm not really sure what the purpose is. Maybe to put it in context. I think that's the proper way. All right, so now we're going to go from grams to moles. Well, where could we find a conversion rate that goes from grams to moles? Well, periodic table. Beryllium. Let's look it up. Beryllium's right here, right? Periodic table. I just cut that out. So we're going to start here with beryllium. And we have 3.24 grams of beryllium. And we want to go here, moles of beryllium, right? So I'm going to write some fractions. 9.012 grams of beryllium over 1 mole of beryllium, or 1 mole of beryllium over 9.012 grams of beryllium. All right. This was step 2 in the conversions, right? So step 3 is take your original value, 3.42 grams of beryllium, and we multiply it by the fraction that has grams of beryllium on the bottom. So it's going to be this one. 1 mole of beryllium over 9.012 grams of beryllium. Grams of beryllium cancel out. This is going to be, the answer is going to be moles of beryllium. All right, let's plug this into our digital calculator. 3.24 divided by 9.012. All right. Let's use this other one. Let's clear this. 3.24 divided by 9.012. Let me just make sure I did that right. 3.24, 9.012. And we got 0.35952. 0.35952. We have 3 significant figures. We need 3 significant figures, so it becomes 0.359, but we have to round up. So that actually becomes 0.360 moles of beryllium. Remember, moles is just a thing. Moles is just the number of things. So if we said we had a half dozen, 0.3 of a dozen, this is 0.36 of a mole, right? All right, let's continue. Mass, moles of gold, right? So what is the mass of 2.561 moles of gold? So we have 2.561 moles of gold, and we're trying to find mass. So mass is measured in grams. So we have grams of gold. Where could we find a conversion rate that goes from moles to grams or grams to moles? Well, periodic table. So it's going to be 197.0 grams of gold over 1 mole of gold. Or, again, write two different fractions. And you might be at the point where you can just stop writing these two fractions because you've practiced enough, right? But let's check it out. Again, this was step 2 in the conversion. Step 3 is you take your original value, 2.561 moles of gold. Remember, we're going to use the fraction with the same units on the bottom of the fraction as the original value. So since moles of gold are on the bottom, we're going to use moles of gold on the bottom. 197.0 grams of AU. So 1 mole of AU of gold. These cancel out and it becomes 2.561. Let's go to this one now. 2.561 times 197, which is matter 504.517. So this is 504.517, but what do we do? Units, grams of gold. This is 4 sig figs. We're going to have to cut it off at 4, becomes 504.5 grams of gold. Now let's use this table, right? We started out here now with moles. And we started out at 2.561 moles of gold. And we're trying to go to grams of gold, right? This is our end. So we're starting here. We're going to move across this arrow. We have to use number 1. This arrow tells us use the grams per mole from the periodic table, right? And that's what we did. All right, hopefully this is getting a little easier. Remember, do the last lecture first before doing this one. This is like a continuation. It's hard to do these separate, right? So make sure you do the last one first. All right. Now it's saying a prospector paying for gold, which is kind of fun, by the way, collects 15.00 grams of pure gold. How many gold atoms are there in this quantity of gold? So let's check that out. 15.00 grams of gold, and they want to go to atoms of gold. If you're not super familiar with this, let's use this conversion table. This is our start. We have 15.00 grams of gold. This is our end because we want atoms, right? Units or atoms, right? So this is our end. We're going to start here. We're going to cross the first arrow, or first number. Across the first arrow, and that's number 1. We're going to use the grams per mole from the periodic table, right? So conversion 1, sorry, it goes from grams. Now we're going to go to moles of gold, right? Now from moles of gold, we're going to go to atoms of gold. So it's a 2-part conversion. I'm going to label these conversion 1, conversion 2. Let's do the fractions for conversion 1. 197.0 grams of gold over 1 mole of gold. Remember, anything grams to moles, periodic table. Moles of AU to 197.0 grams of AU. All right, second one, it says use 6.022 times 10 to the 23rd units. We'll call it atoms this time. right? So 6.022 times 10 to the 23rd atoms is 1 mole. And we can do it specifically, atoms of gold to 1 mole of gold, even though it's the same thing, but let's just put it in there anyway. This is 1 mole of gold, 6.022 times 10 to the 23rd atoms of gold. All right, let's do it. 15.00 grams of gold. We're going to use the grams of gold where it's on the bottom of the fraction. 1 mole, 197.0 grams of AU. Now, I'm going to do a little advanced step here. I'm going to do this in one operation. Let's cancel stuff out first. All right. Grams of gold cancel out. Now we're left with moles of gold on the top. So now we're going to have to find moles of gold on the bottom, which is this one. Right? Because we have the moles of gold. We're going to let our unit in the original value dictate what fraction we're going to use. Over 1 mole of gold. Now look what cancels out. 1 mole of gold. And we're left with atoms of gold. All right, let's try this now. In the calculator, again, we're going to do, remember, PEMDAS is parentheses, exponents. I'll write this down here. PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. Multiplication, division from left to right together, addition, subtraction. We don't really have any of that. We don't have any of this. It's just multiplication, division from left to right. Okay, so let's do that. So it's going to be 15. Let's do this one. Let's clear this. 15.00 times 1 divided by 197.0 times, oops. So here, actually, this is a good way to do it. So here, let's actually go back and we're going to move over the arrow a bit, divided, or sorry, 197.0, but we're going to move over a bit and then multiply the whole thing by, and again, since we're using exponential notation, we're going to say 6.022. We're going to use those brackets times 10 to the 23rd. We're going to move the arrow, close brackets, divided by 1. All right. So that's going to be 4.585 279. 4.585279. 4.58279. Let me just 4.585279 times to the 23rd. Oh, sorry, 10 to the 22nd. I would have made a mistake there. Atoms of gold. We started off with 4 sig bigs. So we're going to cut it off at 4. 1, 2, 3, 4. Cut it off there. It becomes 4.585 times 10 to the 22nd atoms of gold. A little more advanced, right? But we're going to use this little table to get us through these because it gets confusing. In the beginning, I highly recommend using the table. As you get better, just stop using it, right? It's just for you to help, right? If you don't need it, don't use it. If you think it's more confusing, don't use it. I recommend trying it first. If you don't like it, don't use it, right? You can do it without it. But this definitely helps a lot of beginning chemistry students. All right, so let's now keep rolling. I'm just gonna zoom ahead a bit. Okay. All right, let's do another one. How many moles of sucrose are there in a 25-gram sample of sucrose? So let's write this out. 25 grams of C12H22O11. And we're trying to get to moles of C12H22O11. Well, grams to moles, periodic table. Here we have carbon, we have 12 atoms. Each of those carbons are, on the periodic table, 12.01 grams per mole. Hydrogen, we have 22. Each hydrogen is 1.008 grams per mole. Periodic table. Oxygen, we have 11. Each of those is 16.00 grams per mole. All right. Let's do the math there. Let's do this. 12 times 12. I'm going to do it all kind of, it's like our calculator reset. Let's try this again. All right. 12 times 12.01. And then I'm going to do 22 times 1.008. And then we have, I believe, 11 oxygen. So 11 times 16.00. Cool. So 144.12. Again, that's grams per mole. 22.176 grams per mole. And then 176 grams per mole. We add those together. Let's do that. So we're going to say plus 22.176 plus 144.12. And I got 342.296. 342.296 grams per mole. All right, so let's do that. Original value, 25 grams of C12H22O11. So here, let's say write this as fractions because it's a little wonky. So let's just clear it up. Grams per 1 mole. And this is 342.296 grams per 1 mole. And actually, let me write this out just to be proper. Sometimes I take a little too many shortcuts and people get confused. So let's make sure that doesn't happen. C12H22O11. 1 mole of C12H22O11. I just repeated that. Let's fix that. That should be on the bottom. Right? So again, we're going to write two different fractions. That means we have to flip the top and the bottom. H22O11, and this is or 342.296 grams C12H22O11. Well, look up here. This is grams of C12H22O11, otherwise known as sucrose. So here we see it on the bottom. That's what we need. So we're going to use this one. This is going to be 1 mole C12H22O11, and then 342.296 grams C12H22O11. Pull up what cancels out, boom and boom, and then we have 25 divided by that number. So we're going to say 25 divided by 34296. That's going to be 0.0730. 0730 moles of sucrose, C12H22O11. All right, but we need two significant figures. So we need two significant figures. So 0.073 moles of C12H22O11. All right. We are doing it. All right, just a couple more slides and then this is it. But let's get to this other one. All right, mass of, oh, sorry, I forgot to show you here. Right here, we started off with grams and we ended in moles. So we just crossed that one arrow, right? All right, let's take a look here. Let's start with the box first and make that a little easier for us. So what is the mass of, so this is what we're looking for, 0.443 moles of N2H4, and we're trying to go to grams of N2H4, right? So this is now we're going a little backwards, start, and this is our end. So we're going from moles to grams. We're crossing arrow 1. So we need to use the grams per mole from the periodic table. So it's almost exactly the same thing. Let's do it. N2H4, right? We have N, we have two of those. Each of those are 14.01 grams per mole. H, and we have 4, that's 1.008 grams per mole. I can do this math in my head. And this is 4.032 grams per mole. So that looks like it's going to be 32.052 grams per mole. I may have made a mistake. If I did, please let me know and I'll fix it. All right, so here, let's write it as fractions, 32.052 grams of N2H4 per 1 mole of N2H4. Or let's turn it around, N2H4 over 32.052 grams of N2H4. Well, original value, 0.443 moles of N2H4. We have moles of N2H4, so we need moles of N2H4 in the bottom. So we're going to use this conversion rate. 32.052 grams of N2H4 over 1 mole of N2H4. These cancel out, and we got 0.443. So let's clear this. 0.443 times 32.052 times 32.052. And I got 14.1990. 1990, and that's grams of N2H4. 14.1990. Okay, cool. So I got here, it's 3 significant figures. Here is 3 significant figures, so it becomes 14.2 grams of N2H4. Okay. All right, close to getting done here. Let's check it out. Now we're going to do another extra step. You can make your own conversion rates from the ratio of atoms in the molecule. Let's check that out. So here We're going to look at the ratio of water or atoms of hydrogen to oxygen, right? Or atoms in water to the molecule of water, right? So if we have one water molecule, how many hydrogens is that, right? H2 means there's two hydrogens. So this is two hydrogens. So the ratio is one molecule of oxygen to two atoms of hydrogen. All right, what about now one molecule of water? How many oxygens are there in one molecule of water? Well, it's only one, let me make it a little bit, one oxygen atom. Let me just clean up these ones a little bit so it looks like ones. All right, same here. If we had barium fluoride and we're trying to find atoms of barium, molecules of barium to atoms of fluorine, right? We can see that there's every one molecule of barium fluoride. Sorry, that should be a lowercase too. Let's do this right now. Fix it on the fly. And then let's do this one too. All right. Looks better. Let's go back to work here. All right. One molecule, you can see that there are two atoms of fluorine. Here, there's one atom of barium. So we know every molecule has two fluorines and one barium, just like a sandwich. A sandwich has two pieces of bread, and my cheap sandwiches I like to make are just one piece of cheese, right? So the ratio is for every sandwich, there's two pieces of bread. For every sandwich, there's one piece of cheese, right? But from that ratio, we're able to make our own conversion rates, right? Our own conversion rates here. This is a fraction that we can use, another fraction we could use. It lets us convert now from molecules of barium fluoride to atoms of barium, or molecules of barium fluoride to atoms of fluorine, or atoms of fluorine to molecules of barium fluoride, or atoms of barium to molecules of barium fluoride, right? So we're going to expand on our little table here. And I created this little dotted line, right? These have to have everything on this side of the dotted line has to have exactly the same formula. Everything on this side of the dotted line can be a different formula, right? And this will let us convert between molecules and atoms. All right, so let's try that. Let's take a look here. All right, it says how many C4H10 molecules are contained in 9.213 grams of this compound. Then it says how many hydrogen atoms. All right, let's take a look. Let's use this table to get us started here. It says this is our start because we have 9.213 grams of C4H10. All right, so then we're trying to go to C4H10. I like writing it a different way, so let me just fix that. I like saying molecules of C4H10. All right, but how do we get there? Well, this is our start, and we're trying to get to molecules, right? Because we have grams. So we need to cross this, and we need to hit moles. So we need to go moles of C4H10. And then we go again, if you get molecules, we have to use the Avogadro's number, and we go here, right? That's going to be a one-step and a two-step conversion. So let's try that out. We have carbon. We have four of them. That is 12.01 grams per mole. Periodic table, it's going to be 48.04 grams per mole. We have 10 hydrogens, 1.008 grams per mole. That's going to be 10.08 grams per mole. Together, that looks like 58.12 grams per mole of C4H10. All right, so now we have our grams per mole. Yeah, let's start here. So we have 9.213 grams of C4H10. We're trying to get to moles, and we know we have to have grams on the bottom, C4H10. Well, that's going to be the 58.12 grams per 1 mole of the C4H10. Let's stop there and cancel these out. Oh, let's make this one long equation. Yeah, so let's do this now. So next we have to do conversion 2. Here, we're going to use this conversion rate. So what goes on the bottom? 1 mole. So it's going to be 6.022 times 10 to the 23rd. In this case, this is a molecule, because it's more than one atom, of C4H10 over 1 mole of C4H10. Now you can see these cancel out. And we're left with molecules of C4H10. All right, let's do the math here. We'll get this going. Let's clear this out. Let's do the math. 9.213. So 9.213 times 1 divided by 58.12 times, and then brackets, 6.022 times 10 to the 23rd, arrow, other brackets, right? And then divided by 1, which you can leave the ones out, but I like doing them just to show you. All right, so it becomes 9.545. Let's just say, let's round that up to 9. 9.5459. 9.5459 times 10 to the 22nd molecules of C4H10. Right? All right, so let me just clean that number up a bit and then we'll move on here. All right, so we're here. We said now there are 9.5459 times 10 to the 22nd molecules C4H10, right? That answers this question here. But we have one more part of the question. How many hydrogen atoms? Well, let's check this out. If we have 1 molecule of C4H10, how many carbon atoms do we have? Well, we have 4 atoms of carbon. If we have 1 molecule of C4H10, we have 10 atoms of hydrogen. If we have 1 molecule of C4H10, how many total atoms do we have? Well, 10 plus 4 is 14 atoms. But this is what we're going to use for our conversion rate now. All right, let's do that. 9.5459 times 10 to the 22nd, right? Molecules of C4H10, right? We're going to use a conversion rate with molecules of C4H10 on the bottom, right? Because we have to put it here because one molecule C4H10, and we have 10 atoms of hydrogen. All right, so these cancel out. Multiplied by 10, it becomes 9.5459 times 10 to the 23rd atoms of H. All right, so then we have 4 sig figs. So here we have to report this as 4 sig figs. So this is going to be 9.54. Let me rewrite some of this here. I'll do it in blue to make it a little clearer, but this is going to be 9.546 times 10 to the 22nd molecules C4H10, right? Because we have 4 sig figs. For this one, it's going to be 9.546 times 10 to the 23rd atoms of hydrogen, right? And this is what the new thing we learned on this slide was, right? So again, this one we're starting out as across the dotted line, right? C4H10. The thing we're trying to find, this one stayed as grams of C4H10. This is now moles of C4H10. We went to molecules of C4H10, but as soon as you cross this line, it's a different formula. Here, it's just hydrogen, right? And let's say atoms of hydrogen, or sorry, let's just do hydrogen, and units is going to be atoms, right? This one's a little tricky. This is probably the hardest thing we've done so far. And this stuff in the blue box, it is the hardest part. All right, practice a lot. Let me know if you have questions, ask in the Discord, and yeah, I'll see you later. Thank you very much. All right, take it easy.